Hello, everyone. Welcome to our joint webinar hosted by P. Cloudy and Test House. We're thrilled to have you with us today for an exciting session on next generation testing with AI, trends, challenges, and opportunities. So, before we dive in, let's cover some housekeeping rules. Your lines are currently muted, but feel free to submit questions during the webinar using the chat option that you find at the bottom of your screen. And we'll address them in the Q&A section at the end of the webinar. And also, please note that this webinar is being recorded, and we'll send out the link of the recording later so that you can share it to the friends or colleagues or have a watch again. So now let's get to know the two awesome organizations behind this webinar. So first up is pCloudy. pCloudy is a cloud-based testing platform offering 5,000 plus real devices and browser combinations for mobile and web app testing. Key features of pCloudy include continuous testing, DevOps, advanced automation, AI-based visual testing, robotic process automation, real-time test analytics, and more. With integration with popular testing frameworks and tools and round-the-clock premium support, pCloudy is trusted by 300K plus registered users from small businesses to large enterprises. So next, meet Test House, a 23-year-old global software testing and quality engineering company based out of London, UK. With a mission to contribute to a world of high-quality software, Test House has helped businesses deliver exceptional user experiences through innovative quality engineering and quality assurance solutions. They focus on enabling total quality management for technology-driven businesses is all about harnessing change and innovation to benefit customers. So pCloudy and Test House have joined forces in a strategic partnership to revolutionize digital testing and quality assurance. Next slide, please. So this partnership combines pCloudy's advanced cloud-based testing platform with Test House's extensive experience in software testing and quality engineering. Together, we are better positioned to provide a seamless testing experience for businesses. A key aspect of this partnership is mutual expansion into new markets with Test House strong presence in the Middle East, UK, US, and Australia, helping pCloudy solidify its global reach. So this is the beginning of an amazing partnership, and we aim to help more businesses deliver unparalleled value to their customers around the world. So now that you know a bit about both pCloudy and Test House, it's time that we move on to the main event. So we are honored to have George Ukru, Chief Solutions Officer at Test House, as our speaker for the day. George has more than 2 decades of quality engineering experience and has worked with numerous Fortune 500 clients in implementing agile testing practices. He has also carried out more than 3 dozen maturity assessments using digitized frameworks and value stream maps to define roadmap strategies for agile, DevOps, and cloud transformation. So some of the use cases implemented include automated user story reviews, self-healing automation engines, and bot-enabled data provisioning. So with his wealth of knowledge and expertise, we're confident that this session will be both informative and inspiring. So without any further ado, let me hand it over to the speaker for today, George Ukur.
Thank you, Geraldine, for the introduction. Good afternoon, everyone. This is George. So today we're actually going to take a look at how is that we can actually use artificial intelligence to improve or to enhance the way in which we actually do testing. So we look at some of the interesting trends. We'll also look at what is happening in the quality engineering world. What are some of the day-to-day challenges that engineers are dealing with, and also see some innovative solutions which can be applied to your day-to-day work. So we're just going to initially start off by looking at the factors that influence quality engineering. We're going to take a deep dive into challenges. We're also going to take a look at some of the tools as well as solutions, and then we'll wind up with a set of best practices that will enable you to implement artificial intelligence-based testing solutions in an enterprise. And then we'll also have enough time for Q&A. We've also planned a couple of demos. Based on the time frame that we're having, we'll try to include them as part of the solution presentations. So if you look at software testing as a stream, there are a lot of things that have actually that has changed in the last, I would say, 4 to 5 years around software testing. You might have seen that almost every organization now is under what you call the influence of agile. So agile is no longer a trend; it has become a norm. So almost every organization actually has agile projects running. I would say like 95% of the projects are still are currently run maybe in an agile mode. And there is an equal amount of implementations happening around DevOps practices. So the amount of DevOps adoption or the number of companies have adopted DevOps practices as well as platforms have actually increased significantly in the last, I would say, 2 to 3 years. And there are organizations who have gone with traditional DevOps tools like Jenkins, Puppet, all of those combinations. And then there are cloud-based DevOps tools being used by organizations who have already moved to the cloud or have plans to move towards the cloud platform. A good example of that is maybe something like Azure DevOps. You also see, just like a DevOps adoption, you also see a large number of customers moving towards digital-based solutions. So I think it's digital-first strategy is what is being applied, whether it's a small business, medium business, or large business. Everyone actually has a digital front end. So there's a lot of investments going on into digital. At the same time, there is also an equal amount of focus around moving to the cloud. So either the existing applications that are running on-prem are actually being migrated to the cloud, or customers are actually going ahead with solutions that actually are hosted in the cloud, like a SaaS-based applications like CRM Dynamics or Salesforce. Now, because of the adoption of DevOps and because you're actually having cloud as well as digital transformation happening in many organizations, the pure functional testing kind of skill is not the only thing that you might need in order to survive in today's software testing world. Because the type of testing that you might do on these applications, let's take an example of maybe a cloud-based application, is very different from what you might have done in the past, especially with maybe like if you're a very senior person who have been in the industry for the last 2 decades, you would have started off with mainframe or monolithic kind of applications, or you might have tested 2 tier or 3 tier kind of client server applications. And then you might have also seen API based applications, and now you're also seeing microservices and others. So, and serverless architecture. So the type of testing you'll have to do on these cloud or what you call digital based applications is very different. So you may need to actually have those skills, and there is not a lot many people in the testing industry who are having enough knowledge around these skills. For example, let it be the fundamentals of a cloud solution like Azure, or let it be advanced concepts around cloud, like maybe knowledge around the cloud infrastructure like Dockerization, Kubernetes kind of architecture, or it may be specific type of testing that you may need to actually do on a cloud-based application like chaos engineering, for example, using a tool like Gremlin or Azure Chaos Studio. So the type of skills that you will have to possess in order to test an application that is actually hosted in the cloud is very different. And you might actually find that there are not many people in the industry who have these skills, who can be readily employed. So there's definitely a talent shortage. There are plenty of jobs for skilled people, but you may not actually have enough people who has the required skills that you may be looking out for. And also, one more interesting trend that is seen is around low code, no code development. So instead of traditional development, there are a lot of challenges that customers are facing around custom development. One is, again, there is a skill shortage to get people with that required skill. It is not easy to get full stack developers. The time that it takes to develop a custom application is actually high. So customers have gone either with the SaaS-based package, which is again a cloud-based solution like CRM Dynamics or Salesforce, or they've decided to go ahead with solutions like OutSystems or Microsoft Power Apps, which are basically low-code, no-code kind of solutions, which can be quickly deployed into testing. So how does it apply? So one case is basically like the type of testing that you're trying to do on low code, no code is very different. You cannot actually follow the same strategy that you are following for your custom development to test low code, no code applications. So the type of testing is different. The speed is very important. Just because of low code, no code, since the development is faster, testing also needs to keep up with the pace of development happening. And also, I think many organizations, even who have gone with custom development, where there is DevOps, the speed is very important. So you need to be actually testing applications with speed, but you may need a totally different skill set to test these kind of applications. But having said that, the amount of budget that is available for testing has not increased. In fact, it has actually reduced. So there are a lot of constraints that you might see around cost, around making investments to actually try out new things, or maybe investments that are actually made on tools. You may actually have constraints all over the place. But overall, what I wanted to cover is basically the type of testing that you might do is very different because of cloud DevOps as well as the adoption of no-code platform. You don't have enough people in the market who actually have the required technical talent or even the domain talent to actually test these applications. And then it's also important to understand the fact that there is constraints around the cost. But there is definitely a demand to actually put in applications into productions at a much faster pace with high quality. That intent is there, but the only constraint that you might have is on the budgets that is actually given to these projects to implement testing. Now, if you look at some of the challenges, if you look at maybe from a, what do you say, if you look from a test engineer standpoint, you may actually have a number of challenges that you may have to deal with on a day-to-day basis when it comes to software testing. So you may be an automation engineer who might have written thousands of tests, but you may be actually facing issues when you're trying to run them in a formal regression cycle or as part of a DevOps pipeline, where you might be facing challenges with respect to a lot of tests failing because of script related issues. So your test may not be very stable, or your application UI might have changed, and you may actually have a lot of tests that are actually failing when you're trying to run it for what do you say, a formal regression cycle. And you may have to spend a lot of time in order to maintain them. The other aspect can be like your developers are actually making all types of changes. You might have patches going into production, you might have minor enhancements, but you really don't know what is that I should be testing for these changes, because it is not known to you like what portion of the code is actually getting impacted. So basically, either you do one thing, you basically take a lot of assumptions, make assumptions, and then do a regression test as well as testing of these patches, or you basically do 100% coverage testing, in the sense like you execute everything that is available in your regression pack to make sure that there is no impact. But you're again spending a lot of time to actually run these tests. So first factor, you don't know what has changed, but at the same time, to mitigate that risk, what you're trying to do, you're actually trying to run large volumes of tests, whether it's automated or manual, without really looking at what is actually being changed by the development team. So you may have longer test cycles, even though you've automated your test cycles, you may be actually running it for long because you have actually run all your tests across different configurations as well as combinations. You may also you may be actually creating a lot of data as part of your testing, in the sense like you may be actually looking at maybe getting a lot of things within what I would say within your test management tool or defect management tool. But the data that you're actually creating is not really used for any kind of insight generation or to make any kind of prediction. So that means that data is there, but the data may not be used for the right purpose. And then you may also be facing challenges around the experience that you're providing to the users. You may be actually doing technical testing, but in most of the cases, we basically fail to look at what are the pain point that your end customer is actually facing, and we don't actually tweak our testing to suit the customer's needs. So we just follow the technical requirements or the functional requirements, but we actually forget to look at or identify what are the key pain points that are faced by the end customer, and then what do you call carry out testing to align with those pain points or the solutions that your development team would have created to address those pain points. And then we may also have other hindrances or other type of challenges coming in when it comes to testing. You may actually face issues with respect to test data provisioning, for example, where you may not have enough, you may not get the right set of data provisioned to your environment on time. On an average, what we've seen is like it takes approximately around 3 to 3.5 days to actually get the complete test data provisioned to an environment before the test cycle starts. So you may actually face delays even to start testing. So one is basically like you really don't know what your developers are changing. You are not aligning your testing based on the customer's pain points. You're executing too many tests without knowing what needs to be regressed. You're creating data, but we're not using it. And then there are also what you call operational challenges with things like test data. These are very, I would say, like maybe top, maybe like 6 challenges. You may have another maybe 25 or 50 different challenges that you may face, but it is just to give you a view of the day-to-day challenges that are actually faced by a software testing team. Now, if you move ahead, one of the other interesting things that you might see is there are a lot of tools that have come in the recent past around testing, and some of these tools may actually have AI capability. There are two things that you need to keep in mind when it comes to AI. So it's a relatively, I would say, like maybe like 8 years back, when a customer had actually given me a use case where he or she was basically looking out for a solution to reduce the number of tests that they were executing for a regression cycle. So they had thousands of tests that they were executing, and they're looking for an AI-based solution to actually solve the problem around test execution. But that point of time, 8 years ago, there were not many products that actually had this kind of capability. I would say AI was mostly a research topic at that point of time. And there are not many companies or custom solutions that were available which could actually do anything like test analytics to decide upon what needs to be actually regressed for a software change that is actually happening. But then on, I think the last, I would say 4 years ago, I think one of the interesting things that I observed is basically like customers are trying to do proof of concepts either by developing custom solutions with the help of an innovation team, or they're trying out with some of the products that are available in the market around testing, basically testing tools which actually had AI capabilities. Many of them did not go forward, but I would say like maybe like 1% of the companies were successful in implementing such solutions. But in the last 2 years, customers, I think I could actually see a lot of maturity coming into these, at least in the commercial space. Even though open source space, there is not much of maturity that we could see. There is definitely a lot of maturity that is actually coming in, that has come into the AI-based solutions around testing, and we could actually see customers having a great amount of success, maybe to solve specific pain points that they were having around artificial intelligence or around testing. Now, so it is basically a maturing area. It started off with a research kind of topic, then it became a proof of concept. Now customers have been able to use AI to solve specific problems. I don't think anyone needs to use AI to solve every problem. So there might be 25 different challenges that you may have within software testing. There may be only like 10% of those challenges may only require AI to actually for a solution standpoint. You may not need to apply AI for every solution that you have, and that's one thing that you need to keep in mind. You need to really know where to apply AI for what kind of solution, because every problem in testing doesn't require AI to be used in order to find a solution. But there are multiple tools that has actually come in for various different purposes. These are just some sample tools that I could actually put in here. One is a tool called DipBlue. We're actually going to take a look at that, which is basically used for test generation. There is a solution called Certifier, as well as there is a solution called OpKey from the same company, with whom we are partnering for this webinar, pCloudy. So we are actually having a solution which can actually do autonomous testing, as well as a solution, a test automation platform that actually has capabilities to do self-healing. We have Functionize, which is again a test automation platform with self-healing capabilities. Apply Tools, most of you would have already heard about this product. It's actually a tool that is used for visual validation or visual regression. You have C-Lights, a test analytics based product, which you're actually going to take a look around, which is basically going to help you to streamline your test execution cycles. You also have a product called Launchable, a relatively new entrant. I think they came into the market around 3 years ago, but this is a very interesting solution. This solution also helps you to cut down on the number of tests that you may be actually running for a regression cycle. They basically use AI models to actually look at your previous test runs and also recommend the test that you should be running for your regression cycle. It also has a very interesting prioritization mechanism that helps you to actually look at what tests you should be actually executing first in order to find the maximum defects. So if you have 100 tests that you want to run, it'll tell you which are the top 25 tests that you should be executing in your cycle first, so that you actually find the most important defects. So there are various solutions around test automation, test data generation, across all the streams of testing which have actually come into the market. Whatever you're seeing is maybe, I would say, like 10% of that. I would say there are at least 4 dozen tools that in the software testing world that actually have AI capability. You're only taking a subset of it. The other interesting factor that I would like to cover before we move on to the AI-based solution is, basically, there has been a fear in the mind of testers earlier itself, before the chat GPT came in, that testing is going to be a stream that is actually going to be taken over by AI. But I think we started hearing about AI 8 years back. Until now, I've not heard any test engineer losing a job because there is an AI solution that is actually implemented. So I think there's nothing to fear about whether it is ChatGPT, which is a generative AI solution, or if you're actually dealing with a traditional NLP-based or AI solution. I don't think there should be any fear in actually adopting any kind of AI-based solution, because they have been designed to actually enable testers to perform better, or they actually help testers to be more productive. In the sense, like these solutions can actually help a tester to maybe create tests faster. In the sense, it can be a productivity improvement that can actually happen. Maybe there are capabilities within AI that can be used to generate tests, maybe from something like an API definition file. For example, you want to generate a set of API tests, and the solution may actually ask you for the place where the API definition file is stored. And then these kind of solutions will actually help you to generate tests from those API definitions files in an automated manner. So you're trying to automate the test design, which is a good example of improving the productivity of testers. Or you may be actually using solutions like customer sentiment analysis, or maybe you're actually analyzing the feedback of the customer using AI, so that you understand what are the pain points that the user is actually facing. Or it can be a solution where you're actually using video analytics to understand the expressions, the facial expressions of the user, to actually understand the pain points that the customer is actually undergoing. when they are using your product. So it can be used to improve the user experience of the overall user experience of your product. Or in some cases, we discuss about the challenge around the test analytics, where or test what you call data metrics, where there's a lot of data that is available, but you're not actually using this data to derive any kind of insight. And that is when test analytics would actually come into picture. You can actually look at the previous runs that you've made. You can actually look at the data as well as the defects that were logged in the past, and you can actually have solutions which actually has test analytics capabilities. Maybe a good example is C-Lights, which can actually guide you on how is that you should be actually going about selecting tests for your regression cycle. So that's a very simple example. So so AI can also be seen as an advisor, where the advices can be given on to a tester around the features that he or she should be testing, or it can be around the number of tests or the type of test that he or she should be picking for validating a particular build that your development team has given. So automating of decision making as well as generating insights from the data that has been generated through testing is one of the good use cases where AI can be applied. Now, AI can also be applied to improve the speed of testing. A good example, again, you talked about launchable as well as test, the C-Light solution. Those solutions will actually help you to decide upon the real tests that you should be running to validate the product based on the type of change that the development team has actually made, which is again a good example of how you can actually cut down on your automation cycle time or even your manual cycle time by actually reducing the number of tests that you're actually executing. You're only executing the most valuable test, which again helps you to cut down on your automation cycle time. So so AI also can help you to do testing faster. And at the same time, there are solutions like self-healing, which will actually cover today, which will actually help you to reduce the effort that you're spending on maintaining your test automation assets. So you're actually spending maybe like 10 hours to actually fix scripts every test cycle because of the changes happening to the UI. You can actually cut down on those efforts, which in turn helps you to reduce the cost of testing. So look at AI from a standpoint where you're actually where AI is trying to help you to be more productive. It will actually help you with recommendations. It will help you to give better experience to your customers. It will actually help you to do testing faster, and also at the same time, it will actually allow you to cut down your overall cost of testing, or you can actually reduce your testing budget by implementing some of these solutions. So today, even though I would say like there are around, I have come across at least 40 plus use cases around AI. We're actually going to take a look at some of the key use cases today. So we'll start off with maybe test automation, which is a stream where you've seen a number of advancements happening in the last, I would say, last 1 decade. And the self-healing is one of the common capabilities that have actually come into a lot of commercial tools, even though you're not seeing this capability in, open source a lot. But there are a lot of commercial solutions like OpKey, Functionize, and even Tricentis who have actually brought in the capabilities around self-healing. So why is self-healing required in the first place? So in today's world, you basically have application releases happening every day or every week, and there is a lot of focus around user experience as well as the overall look and feel of your application. So your application screens may actually undergo changes a lot. And when you're trying to run these test scripts, assume that you've created 500 test automation scripts for a product, and if you're trying to run it as part of your DevOps pipeline, or you're trying to run it as part of your manual, you're manually triggering those test cases, what will actually happen is 10 to 15% of the scripts may fail because there are changes that are actually happening in the UI, or it can be due to other reasons. Your test scripts are actually failing. So assume that you ran 100 tests on the first day, out of which 15 of them failed. Now, someone has to actually do two things. You can do two things. One is basically, if you have an engineer within your team, the engineer can actually go and look at those 15 scripts that have failed, and then you can actually try to go and fix those issues and rerun them. Or what majority of the companies do is basically they try to run those 15 tests manually, because they may not have a person within the team who can straight away go and fix those issues. So the approach that will take is approach number 2, where you actually go ahead and run those 15 test scripts manually. So you may not actually complete your tests on time. Your test cycle may get extended because a lot of tests have failed, because the first day itself you have 15 tests failing, and someone has to manually go and execute these tests. And since you've implemented automation, you may not have enough bandwidth in your team to run these manual tests also. So you may really struggle to complete the execution on time. And often there are slippages. And after the execution cycle is complete, you basically go ahead and run these scripts or fix these scripts, and then run them to make sure that it actually works the next time. And this gets repeated for every test cycle. So you actually spend a good amount of time either doing manual execution because your automation script did not work, or you basically go ahead and fix the automation scripts manually so that you can actually use it for your formal regression cycle. And test scripts fail due to multiple reasons. It can be basically your UI is actually changed. There are new objects that have been introduced. So you may need to actually relearn those objects, or the new objects may not be there in the object map that you have created. You may actually have objects getting renamed. The developer has actually accidentally renamed some of the objects, or the developer has actually, what do you say, change the properties of some of the objects. So your script is not able to recognize the objects when it is actually running. Or it may be an environment issue in the sense like you're trying to reach out to a website, first time did not come in. So you may actually have to look at, what do you say, retrying it. Or your test script is very fast, your application is too slow, or vice versa. Your application is fast, your test script is slow, you're facing synchronization issues. So these are maybe some of the common problems that you may come across when you're trying to run a formal, when you're trying to run your automation script. So first thing, how this is going to help us basically, if you are actually having a self-healing capability within your automation platform, there are two modes in which you can actually run this to implement self-healing. So self-healing, the capability is primarily used to fix these issues that you might actually face when you're trying to run your script. If there are types of changes like the UI changing or new object getting added, synchronization issues, or if you're actually facing environment-related issues, there is definitely a solution that's inbuilt into your platform that is capable of handling these kind of errors, so that your test execution can be smoother and the maintenance of your script is actually taken in an automated manner. So if such a failure happens in your automation during your test automation script execution time, there's an engine that actually goes and understands why a failure has happened, and it also tries to categorize what type of failure it is, whether it is a UI change, whether it is a, what you call, synchronization issue, and then it tries to apply a solution on the fly using which we can actually go ahead and fix the issue. So, for example, you may actually go ahead and try to increase the wait times of the script. For example, your application is behaving too slow. Now, instead of actually stopping the script and updating your variables, which are controlling your wait time, you can actually straight away do that as part of your healing solution, where you can actually improve the wait times of your script on a, what you call, in a dynamic mode. Or you might have new properties that have come into your object, or existing properties have changed. In that case also, your healing solution can have the capability to go and fix that during runtime. So one is basically fixing these issues during runtime. That is one mode of doing self-healing. The other mode of self-healing, which is maybe a lower version of it, is basically looking at whether I can actually do an impact analysis before I run my script to understand what type of changes have happened, and then go ahead and tell the tool to actually, what do you call, go ahead and fix all the issues that it has actually discovered when the auto impact analysis or the test impact analysis is actually done. So it can be done in two ways. So ideally what happens is, whether you're actually doing it in an offline mode or during runtime, whatever fixes are applied, there is a script maintenance log that is actually created or updated, and that is also given to the user so that user also understands what type of changes have actually gone into your what do you say, solution, and then you basically run the script to make it work. So the primary benefit that you actually get by implementing a self-healing solution like the functionized healing capabilities or using OptiMise is, you would have to spend a lot of time maintaining your scripts. Everything is actually run in an automated manner. Even though there are changes happening to your application UI, if the controls are getting changed, the test platform will have, the automation platform will have the capability to go and fix these issues. So you don't have to spend a lot of time maintaining these scripts, which actually improves the ROI that you're actually going to get from test automation. Now, let me show you a small example from Opki itself on how this actually works. So whatever I'm going to show you is basically from an Oracle ERP standpoint, and we have we are we are taking an example of the Oracle ERP application, and we are trying to run the healing in an offline mode. In the sense, like, this is not done during runtime. We are actually using the release 22B version of Oracle and then comparing it with the previous baseline of 22A. And you're actually using an instance which is which is actually hosted in North America. So we are basically running this impact analysis report on the 22B version to understand what has actually changed in the Oracle 22B version, to understand, like, I've written automation scripts, and to also look at what has actually changed in the application and what are the changes that I may have to perform in my application. In this case, there are 3 modules that have changed. And you can also see that there are 5 business processes, and there are a number of test cases that are actually impacted because of a small change that has actually happened in this version of Oracle. Now you're actually digging deep. So we're actually finding out that the changes are actually primarily happened within the finance module. And within the finance module, we're actually going to a sub-module called, what do you call, procure to pay, or a business process called procure to pay. we're actually going deeper, and then we're looking at the actual workflow. So what you see here is basically the test workflow that has been designed, and you can actually find out that there are certain portions that are actually highlighted in red, which actually show that there are a number of things that are impacted. But we can actually narrow down on the particular test that has actually changed, and then go ahead and find out what are the type of change that has actually gone in as part of the new development that has actually happened. So what you see here is you're actually getting into the depth of the workflow. We're actually trying to get into the screen where this change has actually happened. So the changes actually happened in the screen which are related to receipts. So we'll have to go to that particular screen now and then figure out what type of controls have been added. So there is an edit receipt kind of functionality that is available within the form called account receivable, and you can actually find out that there is a new control that has been introduced inside the form, which is actually causing an issue. So what we can find out is there is an add open receivables field that has been added recently, which is actually causing an issue with the script. So now you know that there is something that has changed. So what you can do now is you can actually tell the tool that you can have to go and self-heal this, in the sense like instead of we going and updating all the scripts that are impacted, what can actually happen is you can actually tell the tool to actually go ahead and perform a self-healing where all the what you call objects that are related to this particular screen or the workflow, they are updated now. And then what we can do is we can actually go ahead and run this what we call test workflow again. So we are basically trying to run this workflow again. So what you can see now is basically the test workflow will work fine because the issues have been fixed, and you can actually see that the test will actually pass now. But at the same time, it's also important for us to keep a track of what has changed. So you can also create an impact analysis report that you can actually download and use a version of this impact analysis report so that you know what has actually changed, and you can also use it for reference. That's how self-healing works. It's a very, very simple demonstration from a package application standpoint, but this can be applied. The concept is same, but this can be applied for any kind of application, whether it is mobile, whether it is responsive web, or any of those kinds of applications. Let's actually take a next example, which is around autonomous bots. So what we're going to talk about is basically the testing of a mobile app. Assume that you have a mobile app that is being developed in your organization, and you have to actually what do you call, there are releases happening every day, and the development team is very eager to actually understand the quality of this app as soon as it is released for the testing team. So traditionally what happens is if you want to validate this mobile app, you want to do the basic sanity test on maybe like 5 or 6 different devices. It'll take at least half a days of time to actually get that kind of feedback. But there are solutions like Certifier, which Cloud has actually introduced, which actually helps you to understand, or which helps you to do something like autonomous testing. So you don't have to write test cases to validate the build or the package that has been given to you. You can actually use the Certifier bot to actually validate your mobile banking product or your what do you call e-commerce product, which is basically a mobile app. It's not just the functional aspect. So basically running a what do you call a set of smoke test on your application. You're not just limiting to the functional aspect. As a part of this testing, you can also find out the other aspects of your mobile applications. For example, what is usage frequency, or what is the battery frequency, usage frequency, or what is the type of CPU utilization that's happening, how much of memory is being consumed. So we can validate the basic functional behavior as well as the non-functional behavior, along with the compatibility of your solution across multiple mobile devices. So, and a bot will actually, internally, a bot will actually have a crawling engine which basically understands the data that has been given to the bot for testing. I will show you an example of some of the data that needs to be fed in. You'll also have the capability to do the UI extraction. So the bot will need to understand the different UI elements. It should actually have a mechanism to report what you call and monitor the test, as well at the same time it also needs to understand the hierarchy of the application, in the sense like it should at least have some basic understanding around how your application is being built, what are the different screens that are actually available. And then it also needs to have an action engine, which basically looks at what are the different types of actions that needs to be performed on the application if you want to actually do a functional test. So basically what happens is the only thing that you need to do is you have to give some basic data to your application. You need to you need to provide your mobile app APK file if it's Android. You need to actually decide upon the mobile devices that you should be using for your testing. And then within a couple of minutes, you're actually getting feedback about your product quality. So that is a very interesting feature, as well as a capability that you need to have if you're actually dealing with a mobile app kind of scenario where you're actually having frequent releases, and the development team is very keen on getting the updates around the application quality. I'll just show you a small demo around this. So what you're seeing is basically the Cloud certifier module. So you're actually uploading an APK file here, which is basically a flight application. So you're basically selecting the APK file on which you want to actually apply testing, or where you want to do testing. You're actually using that, and then you're actually providing the username and password that needs to be actually used in order to run your test. So you're basically giving the email address and the password. And then you're also giving one more data. So you're actually putting labels there. There is one more field. So you need to understand what flight you need to book. So you're actually giving the flight to, from and to information. You're actually booking Delhi and one more location. And then you're actually telling the bot to run the test. So the bot, you can either make the report public or private, depending on the need that you have. So the session is active now. And once the session is complete, you basically, within a few minutes, you actually get a report generated, and you'll actually get an email also with the details of the report on how you should be downloading the report. Now the testing is completed. So you're actually getting a report of your testing. You're actually going to the platform. So what you see here is basically there are around 7 devices on which the test has been run. On an average, it's showing you the CPU usage, memory usage, network usage, and battery usage for this particular app. You're also seeing across each of those devices how was the performance of your application. Again, from a non-functional standpoint, there is this benchmark against which you're comparing it. You can also get some insights towards the bottom portion of the dashboard around the various things that were done. There is also a crash test that you have done, which is basically as well as an exploratory test. The crash test is nothing but you're actually testing these apps and opening every screen in the app, and then you're performing testing. So it's not done in a very structured way, randomly opening screens. It's something like a monkey testing that you do. But you also, at the same time, you also measure the performance of the app, and you can actually see these results across all these devices that you've used for testing. In this case, there are 7 devices. So across those 7 devices, how your application has actually behaved is something that you can see. There are detailed error logs. If there are failures happening, you can actually get specific screenshots, and also you actually see each of those screens that are actually covered as part of the testing. So the beauty of this is you're not spending any effort to do this testing. Everything happens within the background. So that's the main advantage here. You can actually see all the screens that were there. So this is what you actually see within a crash test. And similar to this, and there's also a detailed log file that you see. And now there's something called exploratory test also, which is again, what do you say, a more structured test, I would say. This is actually done as part of workflow. So you basically look at what do you call seeing the workflow of your application here. So you're basically looking at all the screens that you have, and you're actually seeing the detailed report. So the exploratory testing is basically created as part of a workflow. You basically go from your login screen to the next screen, home screen, maybe booking the flight. So it's done in a structured manner, whereas the crash test or the bot test is the initial test that is done is done in a random manner. Yeah, the other important use case is around visual testing. So there's a lot of focus around user experience, especially with digital applications, and it is very important to make sure that your applications look and feel is actually good across various platforms. So if you're dealing with banking, you may have multiple channels on which your customers may be actually performing transactions. So it can be a mobile application, it can be internet banking, it can be ATM, it can be a kiosk, it can be a POS. So there are various channels that are available, and it's also important for as a testing team for us to actually provide the same experience to users across all these digital channels. But if you want to validate the look and feel of maybe a website across maybe different what do you call configurations, it may be a very tough job, because if you just want to validate a single field that is available inside a web page, you may need to look at maybe at least 5 different factors. You may need to ensure that the field is visible. You may need to actually make sure that the X and Y coordinates or the position of the field is correct. You may need to look at the height and what do you call width of the what do you call particular object or field. You may also need to look at the background color. So these are basic 5 things that you may need to actually check on a particular field that's available on a page. And then similar to this, you may have 20 different controls. So overall, it's 20 into 5. You're actually looking at 100 different checkpoints that need to be validated against a single page. So doing this manually is impossible, I would say, because you may need to actually spend a lot of time in order to do this kind of manual verification, and it may not be accurate also, because you might have seen a lot of spam mails coming to you where it tells you to actually find out maybe the differences between 2 images. You may struggle to even find the basic difference. It's very similar to that. It's very difficult for us to actually go to every page and then find those things that are not working based on the visual verification that needs to be done. Now, if you want to automate it also, in the example that I mentioned, we are talking about 20 different verification points or assertions for a single page. For what you call 20 different controls and 5 different assertions. You're talking about 100 different assertions that needs to be made on a single page. And the same page needs to validate across maybe 2 different mobile operating systems, 4 different devices each. or you may have to actually do it with portrait as well as landscape mode. So you're actually talking about maybe like more than 32 different combinations on which 32 combinations on which a single page needs to be validated. So it's impossible to do this even using an automated solution. That is when a solution like Apply tools would actually come into picture, where where the platform offers you capability to do visual verification using an image recognition algorithm. So basically, you can either use the Apply tools capabilities as such, or what you can do is you can actually use the capabilities of a test automation tool like Cypress, Selenium, or Appium. You can use the SDK of Apply tools. Use the SDK within your framework. Look at calling the verifications or the capabilities of Apply tools from the framework. And once you call those capabilities, or once you invoke those capabilities, what happens is the Apply tools SDK actually has the capability to extract the DOM of your page or the document object model of your page, and it actually has the capabilities of actually using the capabilities of the visual grid solution. It actually has the capabilities to actually go ahead and create snapshots or screenshots of your page based on the test environment configuration that you're using. And these configurations are actually taken or compared, or these screenshots are basically compared with the baseline images that were actually created for the same test configuration. So you're basically doing an image to image comparison for each test configuration that you might have. A test configuration can be maybe an environment that you're using for maybe iPad, an iOS environment with iPad, and you're trying to do the testing on the new build to see whether the look and feel has changed. So you compare that iPad, what you call screenshot that you're actually captured earlier, which is basically called a baseline, with the new what you call run, or the new screenshot that you have captured as part of your test cycle, and then you're trying to find out the matches, the mismatches between these two. So you're actually doing visual what you call comparison of each and everything field within your web page, and then you're trying to report that as an anomaly. So basically, there are not just Apply tool that actually has the capability, PRC and other capability. Other tools also have similar capabilities. But it's a very good use case from a compatibility testing standpoint. You can actually save a lot of time around writing or designing tests to verify the visual behavior. It can actually bring a lot of accuracy, and then also look at improving the overall, what I would say, the quality of testing, as well as the experience that you're providing to your users. The next test case is around unit testing. So you might have, I think people have been working, our engineers who have been working in software testing for the last 2 decades or more. One of the interesting things that you might have seen is the level of unit testing has not improved a great extent. I have not seen visible improvements in the coverage of unit testing, and that's the reason why you actually find 98 or 99% of the issues during your black box testing phase, because the development testing is not very complete. I don't blame developers for it, because in the current model of working, especially with Agile and DevOps, developers hardly get maybe 2 weeks of time to actually do to make it to actually generate an understanding, or to what you could understand the user story, what have been given to them. They also have to do design. They have to actually write the code. They have to do what you call unit testing, and then they have to hand over the code to the developer, to the testers on a daily basis to actually do testing. So a lot of work that needs to be done on the design and coding side. So developers do not get a lot of time to actually design unit test cases, and that's the primary reason why the development test coverage is low. Now, someone has actually looked at like this as a very unique problem, and a company like called DiffBlue has actually come up with a solution. So strictly on Java-based what you call code, where you can actually look at generating unit test cases using AI-based solution. So instead of actually a developer writing unit test, what you basically do is there's a solution that can actually look at the code, look at the rules within your code, look at the logic within your code, and then look at creating tests that are intelligent tests, which can actually help you to improve the unit testing coverage. So the main challenge is not on executing these tests, even though it's not unless you actually have thousands of tests. If you have a very small code, you can easily generate tests using the solution and then run it as part of your DevOps pipeline. So DiffBlue is such a solution that actually has the capability to go ahead and run tests based on the changes that your development team has actually done, or you can actually generate tests, unit test cases in an automated manner without actually the developer spending time. It also has capabilities to do the coverage analysis. It tells you exactly what portion of the code has been tested using this DiffBlue capability, as well as any kind of manual test that you might have created, that the developer might have created. It also has refactoring capabilities, where it also tells you how that you can actually optimize your code so that it can improve your coverage as well as testability. And it also has a module which actually gives you insights around the type of test that you should be running. For example, I would have written 5,000 unit tests for my entire product. So based on the change that your developer is actually making, it's similar to what you call a solution like test analytics. DiffBlue also has the capability to recommend the number of unit tests that you should be actually running in order to validate a change. that is actually going into production. So it's a very simple tool. It basically works from a development environment. You can the best thing is to basically use the IntelliJ. The demo, even though it's for Eclipse, you can use IntelliJ also. You may need to actually go ahead and add the plugins related to diffblue, and then you have to actually pick the code base that you want to, for which you want to generate the unit test. So initial step was to actually add the plugins of diffblue by going to the path where you have installed it. And once you're done with that, you have to actually go ahead and fix the working directory where you have to actually point to the solution that you're trying to, what do you say, that you're trying to test. And there are certain arguments that you may need to pass. For example, you may need to actually pass on some standard arguments which are required for naming the test that you're creating. And also these, you are also looking at parameters like whether you want to overwrite your existing test or you want to append to the existing test. So there are a lot of small parameters. There are a lot of standard things. You don't have to worry too much about it. But once you give these parameters, once you're done with the arguments, what you have to do is you have to actually save this, and then you have to actually refresh your environment. So you'll get access to the code base which needs to be unit tested. So there might be multiple. It can be a Java package with multiple classes, and you can actually go ahead and generate unit tests for all of those classes that are available within your code. It actually looks at the method level and then generate the test cases. Now the code is there. It's basically a core banking code that is there, where you're actually going ahead and seeing what you call a package called account. There's an account.java file. There are around 4 classes in it, and now you're trying to use the diffblue to generate unit test cases for this Java code that is there. So it's actually started the generation. It is actually going through the code, and then it is actually trying to find out or generate the unit test cases for these 4 classes that it has actually discovered within this Java file. So we look at every class and all the methods within the class, and then generate unit test cases for each of those methods. So there's a beautiful way of improving your unit test coverage, especially if you're a Java shop. It's easy for the developers to go and use the solution. Not a very costly solution. There's an open source or a free version or a community edition as well, using which you can go ahead and create these tests. Now, whatever you're seeing is basically the tests that are actually created for the account class. It is actually generated account test.java file, which actually includes all the tests that are applicable to that particular file, and then you can actually run it as a JUnit test now. So I think it's actually running those tests now. It also tells you what are the coverage that is there, and it also tells you what portion of the code is being covered by these tests. There might be methods that are not covered, but on an average, it actually generates somewhere between 50 to 60% of tests for your code, and then you may need to do further optimization to get better coverage. The last solution that I would like to cover is around test analytics. This is again one more pain point that you might be having, where your developer might be making major changes to the code, or in some cases, developer might be fixing a couple of bugs, and then you're actually putting this build for testing. So you really don't know what you should be testing, because it's very tough to understand the change that has actually gone into the code. So you basically end up running too many tests, or in some cases, you only run a small subset of tests by taking some assumptions, and you may also leak defects as part of this. So you're trying to solve this problem around the number of tests that you want to execute, or the number of tests that should be executed as part of a regression test cycle, by actually applying test analytics, where a solution like CLights will have the capability to actually recommend the types of tests that you should be running as part of your regression cycle or as part of your test cycle. So how this works is basically you may need to execute all your tests at least once. So what happens during that time is your CLights solution will actually listen to the tests that are getting executed, tries to map those tests to a particular component within your application code. You don't have to give the code. It basically does byte-wise comparison. It extracts the code from the byte code, and then it actually tries to do the functional mapping. So CLights now knows, once you complete the baseline run, CLights knows that what test case is actually testing what kind of functionality or capability within your application. Now you're done with that baseline run. Now you have a new build that your development team has actually given you. At that point of time, you basically run an analysis using CLights. So CLights will actually go and find out what your developer has actually changed. There are 3 things that your developer would have done. One is basically developers would have added new methods or new portion of code or new classes to your application. So you can actually go ahead and find out. It tells you that for this portion of the test this portion of code that is actually added by the development team, you don't have any kind of test that is available. You may need to add new tests, or it may tell you that some of the code has been removed and you don't have to execute these tests. So you can actually remove some of your tests. And now it'll also tell you that the developer has actually changed maybe 15 different methods, as part of the what I call build that has been given to you. So you need to actually run tests that are belonging to these methods and then a couple of additional tests. So it can be any type of test. It can be a manual test. It can be an API level test. It can be a UI based workflow test, any of those tests. So it basically looks at your previous baseline run. It compares the baseline run with the code that has been or the new build that has been given to you. And it exactly tells you what kind of test you should be running against each of those what do you call build that has been given to you. It's basically a solution that actually helps you to cut down on the number of tests that has been given to you. It actually allows you to reduce the number of tests and also save a lot of time and cost around running these tests. It's basically a good solution. But if you actually have an application that actually has more than like 4,000 or 5,000 tests, this works very well because you might be spending days together as well as there may be multiple resources who are actually engaged, would be engaged to test these solutions. So basically another good example of how analytics can be used in order to cut down on your cycle time. Now, these are few examples. There are many more examples, but overall, when you're trying to implement any kind of AI solution in an organization, a couple of things that you need to keep in mind is you need to set the or you need to set realistic expectations with your stakeholders. It may not be good. It may not be what you call practical to get results on day one. So you set very practical what you call expectations with the stakeholders so that there is no what you call questions asked if there are delays in getting implementations done. It's not something like the first day itself after the AI solution is actually implemented, you actually start getting the results. It will take definitely some time to actually get to the results. So similar to this, when you're setting a deadline for implementation, also you need to make sure that it's very a realistic timeline because the accuracy of the solutions will only improve over a period of time. You are now actually going to get maybe 100% accuracy on day one or even 70% accuracy on day one, especially when you're trying to do it with a what do you say a custom solution. It's actually a periodic improvement, an iterative improvement that you can expect. So you need to give it time, and the stakeholders who are actually part of this particular solution implementation also need to be educated around it. Now, the second thing is basically most of these solutions will require enough data to be fed in to get accuracy. So the quality of data that needs to be given to your development team or to your AI team for implementation should be pretty good. And they should also be giving them enough data. So if your data volume and the data quality is not good, do not expect a lot of accuracy around the data, the solution. It's very important to keep that also in mind. And then none of these solutions, I would say 80% of solutions will definitely require customization. It is not like one size would actually fit all. So you may need to actually customize the solution. You may need to actually rework on the model to see the required results. So it's not, it definitely takes time to actually implement. But once it is implemented, it will actually run forever. But one should actually focus on continuously improving the quality as well as set some realistic timelines as well as set the right expectations if you're actually getting into a state of implementing AI in your organization. So I'll take a pause now. I'm done with my slides. Now I'm open for questions.
Thank you
Yep.
so much, George, for
Yep.
that insightful presentation. So we've received several questions from our attendees. So
Yep.
we'll do our best to answer as many as possible in the time that we have left. So here's the first question for you. So how does self-healing function in the case of defects? Does the AI model need to learn and comprehend changes in the UI or workflow? Similarly, how do humans learn and understand changes in an application?
Okay, so the AI solution would definitely have the capability to understand product defects. For example, you're actually getting runtime errors. You're actually not able to go to the next screen. So that level of intelligence should be there. So it should be able to understand these type of issues. For example, one of the reasons for failure can be a product defect. So the AI solution should definitely understand the different types of errors that actually comes in as part of the execution. It can be JavaScript error. It can be a page not found kind of an error. So it's not going to actually invoke the healing engine to make any of those scenarios work. So it can be a synchronization issue, test environment behaving slow, or a UI change that it sees. Basically, it can be UI property change or a change in screen position. It actually has the capability to go and rectify it. Otherwise, it may not act on it because it'd be very risky to actually ignore those things. And whenever it's actually making a change, it has the capability to go and fix it or record it as part of the log files. So that, what do you say, it is easy for people to actually understand why a specific change was actually implemented. So that's how it works. But definitely, every healing solution that you're trying to implement, whether it's a commercial one or open source one, should actually have the ability to differentiate between a product error. It can be basically an HTTP error, a JavaScript, or anything that you see on the screen. and maybe fix it. And you're not going to fix anything that is actually what you call like a business rule or a functional validation. For example, you're actually seeing a wrong account balance. So nothing like self-healing would be required to correct those. These are not valid defects, and your step will fail and proceed. That's how it works.
Okay. Okay. So here's the next question. So how do you foresee the role of AI in test data generation and its impact on testing coverage? So what benefits and challenges might arise from leveraging AI in this area?
Okay, so test data is one field where I think there are use cases that we have seen where AI-based solutions can be used. So let's actually look at maybe testing an AI-based solution or maybe an RPA-based solution, which basically maybe using a set of PDF files as an input. So you may need to actually generate thousands of PDF files using various permutation combinations of data. So you definitely need a solution which can actually create that kind of a document. So it's not the structured data. You may also need to generate unstructured data. It can be images. You're actually testing something around images. You may need to actually, what do you say, look at a solution that actually has the capability to generate images. So generation of data using AI capabilities is something, both structured and unstructured, is something that will actually be needed in the future, because there are no too many solutions coming into the market which actually has generative AI capabilities or traditional AI capabilities. And there can be other use cases as well. For example, you can even develop bots, chat bots, using which your testing team can actually provision data or create data based on when they need it. So it's basically an on-demand or a self-service kind of model where AI can be again applied to actually generate a solution that actually can provision data. So these are very simple use cases that I can think about. One is a bot that you can create using AI to provision data. Second is basically using synthetic data generation tools that can actually create both structured and unstructured data for your testing needs. And if you can actually, and one of the challenges that you might face within data generation using synthetic, what you call capabilities, is around data models. So if you can actually have some kind of intelligence where your synthetic data platform can listen to a database or analyze a database and then come up with data models automatically, I think that will be very interesting kind of a solution.
Okay. Okay. So here's one final question for you, George.
Yep.
So do you have any suggestions for someone who's switching their career from a functional or automation tester to a AI tester?
Okay, so I don't think you need to. There is, unless you're actually going to test something around AI in the sense like if there are two ways in which you can apply AI or you can actually be involved in AI. One is you're going to test an application that actually has AI capabilities, for which you need to actually have background around data science, data models, and all of those things, which may require some kind of training and upskill. But if you want to use an application that actually has AI capabilities, for example, let's take an example of maybe sea lights. You have to just understand the solution, but be very clear on the problem that the tool can actually solve. But that doesn't require a lot of upskilling. You only have to do upskilling with respect to the tool. But if you're going with the former, where you're going to test an AI application, then you need to actually learn the fundamentals of AI, data science, the different algorithms, and all of those things. And the types of testing might be very different from what you've done earlier. But using an AI-based solution only requires knowledge around the solution, around the platform or the tool, which can be actually easily be what you call. I think you can acquire that knowledge in a pretty fast manner. I think in a couple of days of time. It is something that I think everyone should be actually looking at. So you should need to look at what are the different solutions that are available, and then look at how is that you can apply those solutions to solve the problems that you might be having. That's the only intelligence that you may need to apply. But learning a solution like sea lights or maybe diffblue is not going to take more than 2 weeks of
All right. All right. So looks like we are out of time for today's session. So in case audience, if you didn't get your questions answered, no worries. So we'll reach out to you directly with those questions answered from George. So we love seeing your engagement and enthusiasm during the webinar. So before we say goodbye, remember that we'll send the recording of this webinar to all attendees. So feel free to watch it again or share it with your friends and colleagues. And a big thank you from both P. Cloudy and Test House for joining us today. We hope you enjoyed it and learned something new today. So stay tuned for more future events and collaborations between P. Cloudy and Test House. So thanks again for being with us today and have an awesome day ahead.
Thank you, everyone.
Thank
Have a
you.
great day. Bye bye.
Bye.